So what we're going to talk about is this scenario where you've got this function f of x, and we've got certain values of x. So x is 0, 3, 6, 9, and 12. And then there's other values, but we don't know those. And what this is going to represent is you driving. All right, so you're driving away from Morgantown for whatever reason. All right, so you're driving away from Morgantown. X is the current time, or the time, not current time probably, time in hours after noon. And f of x is the velocity in miles per hour at time x. So, okay, so like when you're looking at 9 with 61, that means at 9 p.m., what was going on? What does the 61 tell you? And just somebody unmute, answer the question, and you're good.
At 9 p.m., you're traveling at a velocity of 61 miles per hour.
Perfect. So you're going 61 miles per hour at 9 p.m. Does that make sense to everybody? We good? All right. So what we're going to talk about is we're going to talk about 3 questions related to this. And we're actually going to answer them in reverse order. So the first question, we're going to approximate these, but the first question is, how far away were you at 9 p.m.? The second question is, how far did you drive from 6 p.m. to 9 p.m.? And then we'll answer a third question here in a few minutes. But the first thing I want you to do is I want you to read those 2 questions closely, the 2 that I've got on the screen. And I want you to think, okay, are those questions actually 2 different questions? Or is it really 2 different ways to ask the same thing? Or are they related? What's the deal? Is that the same question asked in 2 different ways, or are they a little different from each other? And somebody answer, and it's okay if you're wrong, that's not a problem. Most of us were not doing calculus last week for fun, so it's all right if we don't remember some of this stuff. So what do we think? Are those the same question, or are they 2 different ways to ask the same thing?
They're not asking the same thing. Question 1 is asking total distance traveled versus question 2 is asking total distance traveled within a specific time range.
Okay, real good. And now I couldn't see who that was, but that was a really good question, or really good response. So they're related to each other, but like question 1's, what's your distance away like at 9 p.m.? And then question 2, I'm sorry, you know what? These are definitely not the same. You were right. It's from 2 different, or it's how far you traveled. But question 2 is still how far you traveled. Let's change it to noon. Question 3 is going to be from 6 to 9. But anyway, this is still 2 different things because this is how far you drove. So question 2 is how far you drove. And question 1 is how far away were you at this point in time? All right, so now that I've adjusted it to be noon, it is possible that these are the same as each other. It's the answers are the same. There's still 2 different questions. It's possible the answers are the same. It's possible they're not. What would that depend on? So like, what would cause these 2 things to be different? And what would different answers? And what would cause these 2 things to have the same answer?
If you had stopped when you're driving. Or...
Okay, if you stop when you're driving, might mess that up. Yep. What else though?
If you drove in a straight line.
Okay, so let's make 2 assumptions. Let's make, and I didn't say this, so that's completely fine. But let's assume, and it turns out some of this matters and some of it doesn't. But let's assume you're driving on a flat, straight highway, which is not possible for Morgantown, so we'll pretend. But a flat, straight highway, and that you're driving the same direction the whole time. So like you're driving west maybe the whole time. All right, so assuming that, how could these still be different? And what those 2 guys said, you guys are right. Like that could mess with this. But if you're driving the same direction the whole time on a flat, straight highway, how could these still maybe be different? What would it depend on?
Acceleration.
No, that's okay, but that's just how much like your speed changes.
If you got pulled over,
Okay, if you got pulled over, maybe.
because 95 is an exorbitant speed for most
That's true.
highways.
You probably would get pulled over. We're actually going to talk about that in a little bit. Okay, so more though, let's say that you drove, let's say, and I'm making this up, but let's say the answer to this is 500. Okay, so from noon to 9, you drove 500 miles. Does that mean you're necessarily 500 miles away at 9? If you drove this whole direction, same direction the whole time? No, it depends on where you were at noon. Does that make sense? So there's nothing here that says at noon you started in Morgantown. You may have started at 10 a.m. or something. We don't know. And actually at noon you were driving 43 miles an hour already. So probably you didn't start right at noon. Does everybody get what I'm saying? So, okay, let's pretend like I told you as part of this, at noon, you were 75 miles away. And all the stuff I'm writing in blue is stuff that was given to you. So I told you that already. So given that that's the case, if the answer to number 2 is 500, it's probably not because I just made it up. But if the answer to number 2 is 500, then what is the answer to number 1? Given that you were 75 miles away already.
575.
575. Does that make sense to everybody? Because you were already 75 miles away. You drove another 500 miles. So now you're 575, assuming you're driving the same direction the whole time, which is what we're saying we are assuming. Does everybody get that? Okay, so these two questions, they're closely related to each other, but they're not necessarily the same thing. And if you don't start at 0 miles away, then they're definitely not the same thing. Does that make sense to everybody? Everybody clear? Okay, now, when you're doing these problems, or when we're talking about these problems, it's going to be impossible to get an exact answer because this is all the data we've got. What I want to focus on is how do we answer a question like number 2? Because if we can answer that question, then we can immediately answer question 1. Does that make sense to everybody? So if we're able to figure out question 2, we can then go back and figure out question 1 because we know how far away we were at noon. So the third question is how far, it's the one that I wrote to begin with, how far did you drive from 6 to 9 p.m.? And so I want to talk about that one in detail. And so the only relevant part of the table is going to be this part, the part between 6 and 9. So I'm going to copy that down. And what do we say? 95 miles an hour and 61 miles per hour. Okay. And so this is all that's going to be relevant for that part. Does everybody get that? Okay. And so the problem here, as far as trying to get an answer for how far you drove from 6 to 9 is what? What makes this so hard given the information that I've got for you guys?
Change in velocity.
Yeah, the velocity could change. So like, we don't know whether you sped up after 6 o'clock, like 95 miles an hour is really fast, but maybe you drove faster for a while. At 7:30, you might have stopped for dinner. We did say you didn't turn around, that you drove in the same direction. But other than that, we have no idea. So like between these two times, we don't know how fast you're going, which makes it really hard to figure out how far you drove. And so we're going to have to approximate somehow. And so we're going to assume something that is probably not true. But the two easiest things we could assume, okay, so the easiest thing we could assume is that you have your car on cruise control at 6 o'clock at 95 miles an hour. Does that make sense? Okay, so you have it on cruise control for those whole 3 hours. You're flying, you're going like 95 miles an hour. And then at 9 o'clock, right at 9, you see a cop and you're like, oh shit, I'm gonna get pulled over, and you slam on the brakes. Does that make sense? Everybody clear? Okay, so you have it on cruise control for those whole 3 hours. At 9 o'clock, you slam on the brakes because you see the cop and you start going 61. Is that possible given what you have here? Yeah, that's possible. If that's the case, so if you did drive 95 miles an hour the whole time, then how far did you drive over those 3 hours? So if that's right, if you had it on cruise control the whole time, and then you slam on your brakes right at 9, how fast did you go? What do you guys think? Or how far did you go? Not how fast. We knew that already.
285 miles.
285. Yeah, 285 miles. That's exactly right. Why 285 miles? Somebody explain why he's right.
Just multiplied 95 by 3 hours.
Perfect. 95 times 3 hours. And the idea is you were driving 95 miles an hour the whole time. You were doing that for 3 hours. So if you multiply them, that's how far you went. Does that make sense to everybody? You guys clear? Any questions? Now, like we said, that's probably wrong, but that's one way that this could happen. If that happened, what I want to look at is what the graph then looks like. And so let's do that in black. And let's say we've got the graph. And so, okay, given what we've got, the only thing we actually know about the graph, whoops, is that at 6 o'clock you were going 95 miles an hour, and at 9 o'clock you were going 61 miles an hour. And so the graph has a point here and a point here. And my graph's not to scale on purpose, but that's the part of the graph that's relevant. Does that make sense? Everybody clear? Okay, now if we're right about this and you had it on cruise control the whole time, then what does the graph look like between here? We don't actually know because we don't know what we were doing, but if you had it on cruise control, what would it look like?
Would it be like a flat line and then discontinuous?
Exactly right. It'd be a flat line at 95. And it would be discontinuous because it would jump, whoops, it would jump down to 61. Does that make sense to everybody? Because you have it on cruise control the whole time for those 3 hours. You slam on the brakes and then you start going 61. Everybody clear? Questions? Okay, now, we don't necessarily have to be right about that, but let's assume for a little bit that we are. And what I want to talk about is what mathematically are we talking about and where does this show up on the graph? So, okay, so for a second, 95, that is your speed or velocity at 6 p.m. Does that make sense? Okay, what is the mathematical symbol that represents that? Is that like X? Is that f of X? Is that f prime of X? What mathematically would get us this 95 and would represent the velocity at 6 in this problem? What do you guys think?
F of X.
F of X, and specifically F of 6. Does that make sense to everybody? Now, a lot of times in Calc 1, you talk about the derivative being the velocity, and a lot of times that's true. But if we look back up here, F of X represented velocity. So in this case, F of 6 is your velocity at 6. Does that make sense? Everybody clear? Okay, graphically, how does that show up? So like the 95, is that X? Is that Y? Is that the slope? Is that the concavity? What does 95 show up as for F of 6 on this picture? What is it? So the 95 is the Y value at 6. Does that make sense to everybody? Okay, so this is the Y value at 6. Everybody follow that? You clear? Okay, now, is this always the case? So does f of x or f of 6 in general always mean the y value at 6 if we're talking about the graph of f of x? So is this always the y value? Yes.
Yeah.
If we're talking about the graph of f of x, then the f of 6 always represents the y value at 6. Does that make sense? Okay. Is it always velocity at 6, or is that specific to this word problem?
Specific.
That's specific to this word problem. Sometimes f of x might represent the height or the distance or the cost or the revenue. Well, depends on what we're talking about. Does that make sense to everybody? Okay, but this is specific. So this is the interpretation that is specific to this word problem. These are the units because of the interpretation. So miles per hour are the units, but that's because of the problem up here where we were told velocity in miles per hour. We had to know what that function represented. Does that make sense to everybody? We clear? Okay. So that's specific to this problem. This is the symbol that represents this stuff. And this is the graphical interpretation. Now, that symbol always means this graphical interpretation. As long as you're talking about the graph of f of x, this symbol does not always mean these. These are specific to the word problem. Does that make sense to everybody? Okay, now, let's assume you had it on cruise control before 6 as well, just so we can talk about the next thing. And so the next thing I want to talk about is f prime of 6, which you spend a ton of time in Calc 1 talking about, right? So what would the answer, the numeric answer like 95, what would f prime of 6 be if this graph is right?
0.
It would be 0.
It would be 0. Really good. Why are both of those guys right? Somebody else explain why they're both right. Why is that 0?
Because f prime of 6 represents the acceleration. and
Okay,
it's
in this case,
during that time.
yeah, okay, in this case, it represents the acceleration. She's right about that. Although I never said that, right? She figured it out. So let's talk about why that's true in a minute. But how did we know it was 0? Nothing you said's wrong, but how do we know from here that it's 0?
When you take the derivative of a constant, it's 0.
Okay, and what makes this constant?
It's not
There's no slope.
increasing or decreasing.
It's not increasing or decreasing. What's the slope here?
Zero.
The slope is 0 because it's flat. If I'm right about this graph, does that make sense to everybody? Okay, now all the stuff you guys said is right, but specifically what we're using on this graph is that it's the slope at x equals 6. Does that make sense? Now, does this always mean this? Does f prime of 6 always mean the slope at 6? If you're talking about the graph of f of x? 100% yes. That's the big idea in Calc 1. The derivative at 6 means the slope at 6. Does that make sense to everybody? And then that leads into things like here the derivative would be acceleration and the derivative of a constant would be 0. All of that's true, but the derivative of a constant is 0 because the slope of a constant graph is flat. It's 0. The reason it's acceleration is why? What are the units on the 0 here? Is that 0 miles, 0 miles per hour, 0 hours, or what?
So 0 miles per hour per hour.
Miles per hour, which we're going to write as miles per hour squared. And somebody in physics might not like this, but I think that's basically the same thing, right? Miles per hour and miles per hour squared, those are the same thing. So everybody get that? Anyone know why that's the case? Why are those units miles per hour squared? And the answer, because it's acceleration, is not wrong, but then why is it acceleration? So why is it that when this is y, that this is the derivative?
It's the rate of change of the velocity.
Okay, it's the rate of change of the velocity. That is correct. why does that mean that it becomes miles per hour squared? You're right.
Isn't it essentially a derivative of the units as well?
It's a derivative of the units as well, sure. But then why is the derivative of miles per hour squared? You're not wrong. It is. But why? Okay. Do we remember how you originally calculated derivatives? Most of us have probably blocked this out by now, but it's like the limit as h goes to 0 of f of x plus h minus f of x over x plus h minus x. And yes, those x's cancel and you get h, but this is really how the derivative is calculated because it's a slope. It's y2 minus y1 over x2 minus x1. Does everybody get that? You guys clear? Okay. Now, we learn a lot of ways to not have to deal with this, but that's the basis of everything you're doing in Calc 1 and really everything we're going to do in Calc 2. But because it's y up here, the units are y divided by x. So it's the units of the y divided by the units of the x. Well, y here is miles per hour. Man, that's not neat enough. All right, so y here is miles per hour, and x is hours, which is miles per hour, like the one guy said, and then that simplifies to miles per hour squared. Does that make sense to everybody? You guys clear? Okay, so the units in general are y here, and then here they're always y divided by x. I don't know if that's something you learn concretely in Calc 1 or not. You should, but that's something we want to know, that whatever the units of y are, the units of the derivative are automatically y divided by x. So like way back up here when we weren't looking at a graph, rather than knowing that derivative velocity acceleration, that ends up being true. But the reason it's true is because of what we're saying now. The units of the derivative are y over x, so miles per hour over hours. Does that make sense to everybody? That's clear? Okay, now, I don't want to talk about the second derivative right now that much, but if you were to take the second derivative again, or the derivative again, you divide by x again. So the second derivative units are y divided by x squared, third derivative are y divided by x to the third, and so on. Does that make sense? Everybody clear? Okay, so this is a big deal here. Any questions so far? Now, all of this is related to what we're doing down here, but none of this is 285, right? So our answer on this question was 285, and the units were miles. Does that make sense? Okay, so what I want to know is what is this other stuff? Where does that show up on the graph? What is the symbol for that? What's the interpretation of that? So let's actually start with the interpretation. So when I say how far did you drive from 6 to 9, what's the formal word for that? Velocity acceleration, what is it?
Distance.
It's the distance, and more formally, it's the displacement. Have we heard that word? So it's the displacement, which in this context is the same thing, but this is the displacement from 6 to 9 p.m. Remember at the beginning we said we're going to assume we drove in the same direction the whole time? You guys know what I'm talking about? Okay, so displacement does not assume that. So if you drove like north 100 and south 30, so if you drove north 100 and south 30, your total distance would be, let's draw that down here. If you went north 100 and south 30, what would your total distance driven be? If you drove 130, but what would your displacement be?
70.
70. Does that make sense to everybody? Okay, so what we're going to focus on is displacement. If you don't turn around, you don't have to worry about that distinction. But if you do more than one direction, then there's a difference. Does that make sense to everybody? You guys clear what I'm talking about? Okay, So here we assumed we're driving the same direction, which is why this is the same as displacement. Otherwise, we have to be pretty careful about whether we mean 130 here or 70 here. But anyway, let's go back to it. Where does that show up on the graph, do you guys think? So the 285, where is that over here? Like f of x, f of 6, that's the y value at 6. F prime of 6, that's the slope at 6. Where's this 285, or does it not show up at all?
It would be the area underneath the line.
Perfect. The area underneath this. So if I drew this in and said, okay, what's the area of this? The area is 285. And then I'm going to erase that because it's taking up a spot on my diagram. But does everybody get what I'm talking about? Okay, and let's just draw it down here so that I don't have to worry about that. Okay, so then somehow it's the area under f of x from x equals 6 to x equals 9. Does that make sense? Now, there are two reasons why the area of that is 285. One is because what shape is this? It's not a hard question. What shape is that?
Rectangle.
Rectangle, good. And the way you do rectangle is base times height, right? The base is 3, the height is 95, so the area is 285. Okay, so it's for sure that area. How is it possible that that area is 285 miles? So like if I tell you the area of the screen you're looking at is 60 inches, I'm wrong. Not because it's not 60, but because why? Why can the area of that not be 60 inches?
Units are wrong.
Yeah, the units would be wrong. The area of your screen, if it was 60, would be 60 square inches. Does that make sense? Now, it's not 60 square inches. It's my gross misunderstanding of those units, but it would be square inches. Does everybody get what I mean? All right. So then why is this not square miles? Why is that miles?
Because you're multiplying miles per hour by hours, so the hours cancel.
Yep. So 95 is miles per hour. Does that make sense to everybody? 3 is hours. So the hours cancel and you get miles. Does that make sense? Perfect explanation. That may be the first time that's ever happened in a first day Calc 2 class. Nice job. Does that make sense to everybody though? We good? Okay. Now, that's really good. That's weird though that we would let area represent miles, but we do. It's also weird that this distance on your screen is somehow 3 hours, right? That doesn't actually make sense. That distance might be 3 centimeters, but it's not 3 hours. We're defining it as 3 hours. We're defining this as 95, not miles, 95 miles per hour. So then it's also okay to say, okay, well, then that's 285 miles. That's what our diagram represents. Does everybody follow that? Okay, but in general, the units of the area are then base times height, which would be x times y. Does that make sense? So the derivative is y divided by x. This thing is x times y. What symbol do we use for this? If we're looking for the area under f of x from 6 to 9, what is that?
Integral.
That's the integral. Yeah, so this is the integral from 6 to 9 of f of x dx. Does that make sense to everybody? That's a huge deal. This discussion is kind of the basis of all of calculus. Like everything you did in Calc 1 and almost everything we're going to do in Calc 2 boils down to this stuff and the relationships between this stuff and why we would care about this beyond you not getting a speeding ticket when you're driving away from Morgantown. So like why this has a lot more applications. The derivative is the slope. The integral is the area. Somehow those are opposites of each other. That does not make sense logically. Why area is the opposite of slope, but that's the case. The proof of that is called the fundamental theorem of calculus, and it's a big, big deal. The stuff on the left, these are always true. f of 6 is always the y value at 6. The units on that are always the units of y. F prime of 6 is always the slope at 6. The units are always the units of y divided by the units of x. The integral from 6 to 9 is always the area under f of x. Under's in quotes because it's a little more technical. It's net area. And you talked about that a little bit in Calc 1. But anyway, it's basically the area from 6 to 9. The units are always x times y. This stuff is always true. The stuff on the right, not always true. They're specific to this application. So given that this was miles per hour, then this is automatically miles per hour squared because x was hours, and this was automatically miles because it's x times y. Given what miles per hour means, that happens to be velocity. Miles per hour squared happens to be acceleration. Miles happens to be displacement. Does that make sense? Huge, huge deal that we should have figured out in Calc 1, but it's kind of a big overall summary of that stuff. Any questions? Because it's real important we understand these concepts. Everybody good?
One quick question.
Sure.
Are the term integral and antiderivative interchangeable, or is there some limitations?
They are not. And so there's nothing here that indicates that antiderivative would have anything to do with that, other than if you notice y divided by x is the opposite of x times y. And it turns out that's the fundamental reason why this has to do with antiderivative. But other than that, there's no reason why this would be related to antiderivative. So the integral or definite integral, that refers to the area. That's when you have these numbers here. Does that make sense? Like the 6 and the 9? Those are called the bounds. That's called the definite integral. If you don't have the bounds, then you're talking about the indefinite integral. So let's talk about that real quick. So if I said the integral from 6 to 9 of x squared dx versus the integral of x squared dx, this is the definite integral. And it's the area under there. This is the indefinite integral. Which is all antiderivatives of x squared. And we'll make that a little bit more formal after we talk about the syllabus. Okay, but that's basically the difference. The unfortunate thing is that the symbols are the same and they're both called integrals. The reason the symbols are the same is because of this, and not being sarcastic, this like groundbreaking relationship, that this is somehow opposite. That's a surprising thing. That was a huge discovery. And the fact that those things are equal are the reason the symbols are the same. The reason it doesn't seem shocking is because the symbols are the same. Does that make sense?
Yeah.
Okay, so the word integral, though, could refer to either of those. So indefinite integral and antiderivative are more or less interchangeable. Definite integral is actually something different. And up here, we're talking about definite integral. Does that answer the question without making it more confusing? Sorry.
Yeah, no, that's perfect. Thank you.
Okay, cool. Other questions so far? Okay, now, this graph is wrong, right? Because remember back up here, there's nothing that indicates we were on cruise control. We're assuming you had it on cruise control. And so we don't actually know what the graph looked like. So our numbers here are probably wrong, but this is one way to approximate it. In Calc 1, you should have talked about Riemann sums. Did we learn that and then block it out, I hope? Okay, that's miserable to sit and do Riemann sums. And if you watch my pre-recorded video, which I'll send you a link to, I go through a Riemann sum. We're not going to, because you don't need to do Riemann sums as part of this class. What you learn in Calc 1 is a way around a Riemann sum. And this one is called a left-hand sum. Do we remember that? Because we used the left endpoint. Does everybody remember that? If we had, like, we could have drawn this where it started at the right endpoint, went back, that'd be a right-hand sum. Everybody clear? Okay, and so that's not a big part of this class. Our big thing is let's not do Riemann sums because they're miserable. And so you did that in Calc 1, and then we're going to learn better ways to do it. And you did a little bit in Calc 1. We're going to do a lot more in Calc 2. And so this is the best we can do from here. Does that make sense? What we're going to do is go back and say, okay, well, how would we do a left-hand sum here? And we could approximate the left-hand sum by doing 43 times 3 plus 82 times 3 plus 95 times 3, and then whatever that is, and I'll let you add. But does everybody see how I'm getting that? So like from noon to 3, you assume your cruise control at 43. From 3 to 6, assume your cruise control at 82. And from 6 to 9, assume your cruise control at 95. You don't use 61 because that'd be from 9 to midnight. Does that make sense? Right-hand sum would be a little different, and those details are something that hopefully you learned in Calc 1. You know what? Because I do have a calculator here, I'm going to get that answer real fast. And so 43 times 3 plus 82 times 3 plus 95 times 3 is 660. So my 500 wasn't way off. So that's 660. And so then this is 660 plus 75, which is 735, I hope. I'm going to make sure because I can't do that stuff in my head. All right. And so these are not right answers, but those are approximations. What is important is that the symbol here would be the integral from 0 to 9 of f of x dx. And we know that because it's asking how far. And because of the assumption that we drove in the same direction, how far is the same as displacement. Does that make sense? Everybody clear? And then the symbol for number 1 would be 75 plus the integral from 0 to 9, which would be approximately equal to 660 plus 75. Everybody follow that. And again, all of these are approximations. We happen to use the left-hand sum because it was easy to talk about the speeding ticket example, but you could use the right-hand sum, you could use the average, all that type of stuff you learn in Calc 1. But the point in this class right now is knowing that this is the way you would calculate the answer to number 1. This is the way you would calculate the answer to number 2. And then this big table here. Does that make sense? Any questions so far? Okay, now, the next thing is that if you were to do this in more detail with left-hand sum and right-hand sums, we learned in Calc 1 that that is hard and miserable. And so what we use is the fundamental theorem of calculus to avoid that. And that's the next topic I want to talk about. But I want to take a minute to talk about the syllabus and stuff. And then if we have time, we're going to come back to that here in about 10 or 15 minutes. Does that sound good? Okay. Any questions so far from this stuff?